Welcome everyone to this week's Science News. This week we have new evidence that the dinosaurs were killed by the aftermath of an asteroid impact. Then we have a look at the biggest universe simulation ever, talk about the lost continent that's been found, Roman ruins in spy footage, a new record for a single photon camera, an asteroid that might contain chemical elements which are not in the periodic table, super lightning bolts, solar glass, and of course, the telephone will ring. A new study that just appeared in Nature Geoscience supports the theory that an asteroid impact was the reason why the dinosaurs went extinct. In 1980, the American physicist Luis Alvarez and his son Walter put forward the hypothesis that a massive asteroid impact was the reason for the mass extinction of the dinosaurs. They thought that the asteroid caused massive tsunamis and firestorms. It also kicked a lot of dust into the atmosphere, which blocked the sun. That killed off a lot of plants, and in turn, the dinosaurs starved. At first, their idea was heavily criticized, because that's how it goes if physicists talk about anything but physics. But the discovery of a huge impact crater in the Gulf of Mexico a decade later provided strong evidence for it. It's called the Chicxulub crater. It's not quite settled, though, if whatever caused that crater also killed the dinosaurs, because it's not clear just how that would have happened. The issue is that, theoretically, the grains of asteroid dust would have had neither the right size nor composition to stay in the atmosphere long enough to explain what happened. For the new study now, they analyzed sediment layers of an ancient lake that formed just after the asteroid impact. Their findings give the atmospheric dust hypothesis more support. According to their study, the material shot into the atmosphere by the asteroid was about 75% silicate dust, 24% sulfur, and 1% soot. The silicate dust grains were just about a few micrometers in size. They would have stayed in the atmosphere almost 15 years, long enough to kill most plants and the dinosaurs with them. It's a shame about the dinosaurs, really. I wish they'd have stayed around long enough to chime in on the paleo diet. A team of international researchers have created the largest cosmological computer simulation to date, modeling our universe at unprecedented accuracy. They've named the simulation Flamingo. And yes, that's another one of those smart acronyms. It's short for Full Hydro Large-Scale Structure Simulations with All-Sky Mapping for the Interpretation of Next-Generation Observations. Flamingo is different from previous simulations in that it incorporates all matter in the universe, dark matter and ordinary matter. Most other simulations only track dark matter because there's more of it if it exists, which it may not. Tracking only the dark matter is easier to compute, and in the end they distribute ordinary matter around the dark matter. The new simulation does it both together. Flamingo simulates about 300 billion elements, each with the mass of a small galaxy. It covers a cube with edges about 10 billion light-years long. Their simulation ran on about 30,000 CPUs. As they report in a paper that was just published, they used their simulation to look at some discrepancies between predictions and observations. If Einstein's theory of general relativity was correct, its predictions should match the observation, but they don't. One of the possible reasons for this discrepancy could have been the lack of normal matter in the simulations. But then their simulation with normal matter, it still doesn't come out correctly. Nevertheless, I'm very impressed, and Albert is too. A few weeks ago, we talked about a group of Dutch geologists who said they found a new tectonic plate. Today we have another Dutch team which says they found an entire lost continent. The Dutch seem somewhat paranoid about losing land, don't they? The lost continent is called Argoland. That might sound like something from the Lord of the Rings, but Argoland is believed to have been a real microcontinent, which split off from Australia 155 million years ago. It then supposedly floated north towards Asia before mysteriously disappearing into the Earth's mantle. Or at least that's what geologists thought is what happened. They don't really know because there's been very little evidence of the continent's existence. For the new paper, they collected new evidence from stone samples on islands in Southeast Asia and the northwest coast of Australia. They then used the shapes of the known continents and their geological makeup together with the new information from the samples to create a computer model. They found that these shapes, their makeup, and their expected drift fit together, and they do fit with the Argoland hypothesis. The largest bits of that lost continent slide into place in modern-day Myanmar and Indonesia, and it all fits together. If microcontinents are a thing, can I call myself a micro-billionaire? A group of anthropologists from Dartmouth College has found Roman ruins in declassified Cold War footage. They looked at Roman forts built in the Fertile Crescent, that's an area in the Middle East off the coast of the Mediterranean Sea. The Romans built forts there probably around the year 200. Already in the 1920s, a man named Father Antoine Pourbar used a World War I plane to take aerial photos of the area. He found those forts and claimed they were a defense line. For the new study, they looked at this area again in footage from Cold War spy satellites and arrived at a different conclusion. They saw the same forts that Pourbar had found, though one can see how much they degraded in the years between the 1920s and the Cold War era. But more importantly, they found a lot of other forts too. The top half of the image here shows the ones that were already known, suggesting a defense line. The bottom half of the image shows the forts found in the new footage. This suggests that the Romans used their forts to facilitate trade across the region, which agrees with the idea that the area was the center for cultural exchange during the Roman Empire and not so much a defense line. Fascinating. According to my theory, the Romans even had a space program. It just never took off because their togas didn't fit into the spacesuit. Researchers from the National Institute of Standards and Technology, NIST, say they've created the world's largest single photon camera. A photon is a quantum of light. It's the smallest possible unit of light. So single photon cameras are as sensitive as a camera can possibly be. The new camera contains 400,000 pixels, which is about 400 times larger than the previous record holder camera of its type. This is an example of an image it produced. The new camera is made up of a grid of super thin wires which have electric currents flowing through them. To properly work, the wires need to be cooled to near absolute zero temperature. Then they become superconducting, the currents flow without resistance and basically without noise. That's why the camera is so sensitive. When the photons come into contact with the wire grid, they interrupt its superconductivity. The detector collects the locations and intensities of these disruptions and forms an image from that. The NIST team plans to put this super sensitive camera to use in a variety of fields, including imaging faraway galaxies, photon-based quantum computers, and even biomedical applications which use near-infrared light for imaging. I really like this, but what I'd like to know even more is if you work on single photon cameras, what do your targeted ads look like? By the way, this video comes with a quiz that lets you check how much you understood. A team of researchers from the University of Arizona say that an unusually dense asteroid might just contain super heavy chemical elements that we've never previously observed and that are not in the periodic table. The periodic table tapers out at the bottom because the heavier the atomic nuclei, the faster they decay. But maybe that's not the end of the story. The holy grail of nuclear physics is the island of stability. That's a hypothetical group of very heavy atomic nuclei which are stable again. It's called an island because that's what it looks like if you put each nucleus on a graph where one axis is the number of photons and the other the number of neutrons. The authors of the new paper now say that some of those conjectured super heavy but stable elements might exist in asteroids. They're particularly interested in an asteroid named 33 Polyhymnia. It floats around in our solar system's main asteroid belt between Mars and Jupiter. According to instrumental readings, Polyhymnia is far denser than any conventional material humans have ever observed. The heaviest naturally occurring element on Earth is osmium with atomic number 76. It has a density of roughly 23 grams per cubic centimeter. Polyhymnia has a density more than 3 times higher, about 75 grams per cubic centimeter. The authors of the new study now say that the best fit for the asteroid's density would be an element with atomic numbers around 164. If the Americans get their hands on that stuff, they'll use it to make even heavier cheesecake. Hello. Hi, Elon. You lost $25 billion? What a shame. You could have blown up a lot of rockets for that. Ah, happens to the best of us. Don't worry. Love you too. Bye. A team of geologists say they figured out a key ingredient for lightning superbolts. About 100 times per second, a lightning bolt hits Earth somewhere. But superbolts are not your ordinary lightning. These bolts can be up to 1,000 times more powerful than normal lightning. Luckily, you don't have to worry about them wiping your neighborhood off the face of the Earth, at least not much. They make up only about 0.001% of all lightning strikes, and most of them come down over the sea. The land areas most affected are Chile and Western Europe. Scientists have tried to figure out the mechanisms behind these superbolts for quite some time, but it's remained a mystery how they form and why they occur in those specific locations. For the new paper, they used new data from a global network database and looked for patterns. They found that the energy of lightning bolts increases when they're created closer to the surface of Earth. They say that makes sense because that makes the electric discharge more powerful. It happens more often over the northeast Atlantic and the Mediterranean because in the winter cold air masses hang low there, and in Chile the altitude is high while storm clouds push down on the mountains. So if you live in Chile or the UK and go out in a storm, better avoid waving your fist at the sky. An Australian solar glass company has just received a $30 million investment, pushing the concept of a power-generating window closer to consumer hands. The company Clearview Technologies has created panels of solar glass, which look like normal sheets of glass, but also generate electricity like a solar panel. They collect their electricity by harvesting infrared and ultraviolet light, which are both invisible to the human eye, while letting most visual light through. Clever. The glass collects energy with the help of a nanoparticle layer in the middle of the glass, as well as a special coating on the surface that selects parts of the light spectrum. The nanoparticle layer captures most of the infrared and ultraviolet and transports them to photovoltaic cells around the edges of each panel. The interior coating helps the nanoparticle layer do its job by deflecting any infrared and ultraviolet light back to the panel. That way, the photovoltaic cells can collect more energy. Clearview is not the only company that's working on this kind of technology, but this big new investment will bring their products closer to mass production and to the consumer market. The company says that currently 10 square meters of its glass can generate up to 1.35 kilowatt hours per day under ideal circumstances. That's about as much as a solar panel does on 1 square meter. So it's probably not going to charge your electric vehicle unless you park it in a literal greenhouse. Thanks for listening. We'll be back next week.